videos showed us that graphing absolute value equations or functions isn't necessarily difficult, but it is very time consuming. So what this video is going to cover is a concept called transformations, and it's a graphing shortcut that's going to help us graph more quickly and more efficiently. Just like last time, finding the vertex of an absolute value function is definitely the most important and still the most difficult part. When we are graphing transformations, there are always 4 steps that we always want to do. We are always going to be looking at the function f of x equals the absolute value of x, which has a vertex at 0, 0, and then has a slope of 1 in either direction, as our starting point in quotations. From this function, we then ask ourselves, are we going to be going up or down? Then is the vertex going to move left or right? From here, this gives us the new vertex. Then we're going to ask ourselves, does the function flip? Because we know that this function goes up to the left and up to the right. And then finally, the hardest part is our growth rate. And now growth rate basically tells us if it's not 1, we need to make a new table, at least a mini table. So we're going to go through each of these steps one at a time. So when we are translating the vertex up or down, we always look at what's after the absolute value symbol. So for example, if the function absolute value of x is going to look like this in either direction, there we go. The absolute value of x plus 3 at the end means the vertex is going to go up 3, which means our new function is going to look like this. Everything else stays exactly the same, except that our function has moved up 3. On the one on the right, if we have minus 2, that means we are going to be going down 2. Everything else is going to stay the same, but our new function has a vertex that is 2 below the original function. There we go. So the first thing we look at is outside the absolute value symbols tells us if we're going up or down. Inside the absolute value symbol is going to tell us if we're moving left or right. But here's where it's very difficult and very important that we are trying to create a 0 just like we were before, which means that it's actually going to be backwards. So this value here is -3. Does not mean we moved left 3. It's actually going to be +3 because 3 minus 3 is equal to 0. So just like before, we're going to graph the regular absolute value of x. And then we look inside the parentheses to see if we're going to move that vertex left or right. So I see a -3 here, which means we are going to be doing the opposite. So we're going to be going right 3. And we do that because we're trying to create a 0 inside of the parentheses. So my vertex moves right 3, but everything else stays exactly the same. My next function has a +1 on the inside, so it looks like we're going to be going right 3, but it's going to be the opposite because -1 plus 1 creates our 0. Therefore, we are going to go left 1 from the original vertex. So there's our moving left 1. Here is our new graph. Now the nice thing, if you've noticed here, my graph got a little bit off there. All of these graphs I have just made have been so much quicker than what I had to do in the last video. This is absolutely a shortcut. Now the last 2 parts of this, flipping and growth rate, are definitely difficult. I would say flipping is not as bad as the growth rate is. Flipping is asking you if there is a negative sign in front of the parentheses or the absolute value symbol. So there's a negative sign right here. Therefore, flip is a yes. Growth rate then asks us, is the number in front of the parentheses 1? If it is not 1, that means it's going to be growing either faster or slower. So for this one, the growth is -2, so it's twice as fast. And whoops, as fast. So this is what's a little bit tricky here, and it's very important. So let's graph the original function first. Now, most of the time, if you have a growth rate that's not 0, just make a table. But if you're ambitious, we know that the vertex is still at 0, 0. And we know it does flip, so we're going down. But now, if I plugged in a 1 here, it'd be 1 times -2, so it'd be down here. So instead of going 1 over 1 down 1, I'm going over 1 down 2. The growth rate is twice as fast. So that makes my new function, it's going to be thinner because the growth rate is faster. Okay? So let's look at the one on the left. So for this one, let's do it in black. Negative in front, so the flip is a yes. And for our growth rate, we have 5/10, or a half, which means the growth is half as fast. Now, because it grows half as fast, it's going to make it wider because it's growing slower. So the vertex is still here. We still flip. So now if I plug in the value of 1, I'm going to be going down a half. So I go 1 and then down a half. So I go there. If I plug in a value of 2, 2 times a half is 1 or -1. So there is my growth rate now. It's going to be wider because I'm growing half as fast. And there are all 4 steps that we're using. We are looking at, does it go up or down, then left or right, then flip, and then finally the growth rate. And the growth rate's the one that is definitely the most difficult. Now you're going to see the function written something like this. Now usually these are absolute value bars, but they can also be parentheses as well. Now we want to know which of these points here impact which part. So up or down is the thing outside of the parentheses. So this is impacted by the K. So up or down, step 1. Left or right is impacted by the H, which is inside the parentheses. So there's our step 2. And then finally, flip and growth rate, the reason why I did them together is they're both impacted by the A, which is out front here. So this is step 3. The flip is if A is negative, and then the growth rate is if A is not 1, bigger than or smaller than 1. So that's a ton of information. So let's do one example all together to see if we can put it together. So before we write this on the side, I'm going to write the crazy looking equation just so that we can compare what we saw to what we're looking at right now. And I think I wrote H and then plus K. Now these variables will change all the time. So up or down is the number outside of the absolute value bars. So this is this number here. And I see a -5, so that means this one is going to be going down 5 from the original vertex. Left or right is the number inside of the parentheses, and we want to go opposite because we're trying to create a 0, so that needs to be -3. So that means we are going left 3 from the original. Flip, we look at the value in front of the parentheses. This time is a -1, so that means we do flip. And then the growth rate, though, lucky for us, is still a 1, so normal growth rate. Now we have all of the information we need to graph. Before I do that, though, I always like to graph the original absolute value of x, just so I can look at what the original was. So my new vertex is down 5 and left 3 from our original. So down 5 and left 3. It says that I do flip, so I'm going down, but the growth rate is still normal. So a slope of -1 in that direction and +1 in that direction. And I just graphed this line without making a table and in much, much faster fashion. This is a tough concept. Definitely something that'll take a lot of practice. As always, if you have any questions, please let me know.